In this video, I'm going to be explaining how to find the derivative of a natural log function, or the derivative of a function that has ln. So most books will tell you that the definition of the derivative of a natural log looks like this. Basically, it's saying that you take whatever that input is, find its derivative, and place it on top of a fraction. Place the original input below it in the denominator position, and there's your derivative. So the derivative of a natural log function is the derivative of the input divided by the original input. The most basic form is the natural log of x. So the derivative of the natural log of x is 1 over x, because the derivative of our input x is 1, divided by the original input x, so 1 over x. You could also write that using a negative exponent and say it's x to the negative 1. With natural logs, we want our denominator value to be greater than 0 because we can't have 0 in the denominator of a fraction. That would be an undefined value. So it's always making a statement that says when you find the derivative of a natural log function, assume that that denominator is always greater than 0. Let's do some more examples. It doesn't matter if we have a coefficient in front of the natural log of x. Actually, we're not going to take the derivative of that constant. We're going to shift it out front, and we're going to find the derivative of the natural log of x. So we're going to use that identity derivative. So the derivative of a natural log of x is 1 over x. And then we multiply by 2 at the front again. And we can be left with our final derivative, 2 over x, or write it using a negative exponent, 2 times x to the negative 1 power. If we increase the coefficient in front of the input, that does a little bit different. So we find the derivative of the natural log of 2x. We're going to find the derivative of the input. That's going to be on top of our fraction, and the original input is going to be on the denominator or bottom. So the derivative of 2x is 2. 2 over 2x simplifies to just 1 over x, or x to the negative 1 power. We could use the derivative of a natural log function in conjunction with product or quotient rules or chain rule. Here's an example where we have two functions being multiplied. So I'm going to use my product rule when I find the derivative. I'm going to find the derivative of the first function times the second function plus the original first function times the derivative of the second function. So the derivative of x is 1 times the natural log of x plus x times the derivative of the natural log of x, which is just 1 over x. X times 1 over x just becomes 1. So our final derivative is the natural log of x plus 1. Next example, the natural log of x squared plus 1. Again, I got my input. I'm going to find the derivative of my input and divide it by the original input. So the derivative of x squared plus 1 is 2x, and 2x divided by x squared plus 1 would be our final derivative answer. So finding derivatives of natural log functions isn't too tricky as long as you know your rule. Find the derivative of the input divided by the original input.